Well, hello and welcome to this exercise on average speed using graphical method. I've done 2 or 3 videos already that involve calculations or using calculations to obtain average speed. But in this case, we're going to use graphical method to obtain our average speed. Now, we got given this here and we've got a table here of time against distance here. Now, the car starts from rest and drives 170 meters in 50 seconds. So the question says, plot the distance time graph and determine the approximate speed in meters per second at the times given. Then it says, using this data, plot the speed time graph for the whole period. So in effect, we're going to have 2 graphs here, the distance time graph and the speed time graph. Right. It then goes on to say, what is the average speed in meters per second over the whole period using both calculation and the graphs you've produced? What do you notice, and how can your answer obtained by the graphical method be improved? Right, now this is the graph I've produced, and straight away, if you got this in the exam, what you need to say is that the speed is not constant because that is not a straight line. If the speed were constant, it would have had a straight line from 0 to 50 seconds there. Okay, so now the average speed is going to be the total distance, which is 170 divided by total time, which is 50, and then your answer is going to be 3.4 meters per second. Next slide. Right, now this is where we stopped from the last slide, calculating the average speed, and we got 3.4 meters per second. And the table here is the table I produced from time and my calculation of speed for a given time. I had to do this calculation myself because my graphic package can't do that for me, so there must be some error somewhere. Anyway, you do this by finding the slope at each given time point there. So at 5, at 11, at 18, at 22, 27, and so on. That's my calculation here. Anyway, and then I plot a graph, and then what you notice here is that the graph starts from 0 up to maximum and then down to 0 when it stops. So when the car stops, the speed is 0. Notice also here that I've got what is called the mid-ordinate points at 4, 8, 12, 16, 20, and so on and so forth. Now, what this is saying to me is that I've got the strip between 6 and 10, so it's got 4 time units. So the strips are uniform, and that's 4 time units, 4 time units, 4 time units there. And these lines are the mid-ordinates for each given strip there. And the number of lines here will tell me the number of strips we've got there. So what you then do is you find what this mid-ordinate point here, this speed there is at time 4 seconds, the speed at time 8 seconds from the graph, and the speed at 12 seconds. Now add those up and then divide by the number of strips. And if you add them up, you get 44.1 divided by 12 strips, which is 3.68 meters per second. Now the question says, how can you improve on your result? Now what you then do is you reduce the number of you increase the number of strips as I got here. Now here the width of each strip is about 1 second there, and these are the mid-ordinate points there. All these are the mid-ordinate points for given times there. Okay, now if you add up all the sum total of all these speeds, because that's what they are, and I've got 176.37, and there are 49 strips altogether there. So, and the average speed is going to be 3.59 meters per second. So when the question says to you, how can you improve your result? You can improve your results by decreasing the width of each strip. In other words, you got more strips there. So this was about, compared to the calculation, this one is about 5% out, and this one with base of 4 units is about 8-9% out on this one. So that's your answer. You increase the number of strips, and the more strips you have, the nearer you get to the average speed by calculation. I hope all that made some sense. Please subscribe, and thank you for watching. Bye bye now.